Okay, students, today's topic is electrophilic and nucleophilic addition reactions. So before going to the main topic, we'll again discuss what are nucleophiles and what are electrophiles. Already we have discussed nucleophilic addition reactions, nucleophilic substitution reactions. We'll discuss addition reactions, okay? So what are nucleophiles or what are nucleophile? What are nucleophile? A reagent. What is a nucleophile? A reagent. Hello? Hello? Hello?
Hello, sir.
Okay. There is, I think, internet connection problem. My Wi-Fi is not working properly. Okay. So we were discussing about nucleophiles. A nucleophile is a reagent which can donate, we had discussed, a pair of electrons in a reaction. It's called a nucleophile. The name nucleophile means nucleus loving and indicates that it attacks a region of low electron density or positive centers. It attacks positive centers. Okay. In the substrate molecule, nucleophiles are electron rich. We had already discussed. They may be negative or neutral. Negative ions including carbon ions or neutral molecules with free electron pair. A nucleophile can be represented by a general symbol Nu, and then there is a negative charge. Examples: chlorine ions, bromine ions, iodine ions, cyanide ions, hydroxyl ions, this ammonia ion or this amide ion, water molecule, this alcoholic group, alkoxide, other things. Okay, so these are the nucleophiles. They may be neutral or negative charge. They may have negative charge. They may be neutral or they may have negative charge. Okay, already we know this. Now we come to electrophiles. Electrophiles. Okay, so what are electrophiles? A reagent which can accept an electron pair. It can accept a electron pair, electrophile, in a reaction is called an electrophile. Is called an electrophile. The name electrophile means electron loving and indicates that it attacks a region of high electron density. A region of high electron density, negative centers, in the substrate molecule. In the substrate molecule. Electrophiles are electron deficient. They need electrons. They are electron deficient. They need electrons. They may be positive ions, including carbonium ions, or neutral molecules with electron deficient centers. They may be neutral molecules with electron deficient centers. And electrophile can be represented by E positive symbol. E superscript positive. E positive. These are the examples: hydrogen ions, this chlorine cation, bromine cation, iodine cation. These are the aluminum trichloride, trifluorobromide. These are the some examples, okay, of electrophiles. Now we'll discuss what are the type of organic reactions: addition reactions, substitution reactions. We know organic reactions can be organized into several basic types. Some reactions fit into more than one category. For example, some Substitution reactions follow an addition elimination pathway. There will be addition as well as elimination. Okay, so basically we are concerned only with two types of organic reactions. One is substitution reactions, already we have discussed. Now the other one will be elimination, addition and elimination reactions. Substitution reactions, addition reactions, and elimination reactions. Okay, types of reactions: addition reactions, substitution reactions, elimination reactions, rearrangement reactions, and organic redox reactions. We are not concerned with these two reactions. Okay, we are only concerned with addition reactions. Substitution reactions already we have discussed, and now we are going to discuss addition reactions, and we will discuss later on elimination reactions. Okay, now addition reactions. So in this addition reactions we have to discuss electrophilic addition reactions and nucleophilic addition reactions. Electrophilic addition reactions and nucleophilic addition reactions. This radical reaction we don't have to discuss. We'll discuss radical also in anti-Markovnikov's rule. Okay. Now, in electrophilic addition reactions, halogenation is one of the example. Halogenation. Okay. And nucleophilic addition reaction, hydrohalogenation and hydration. Hydrohalogenation and hydration is the example of nucleophilic addition reaction. Okay. Now, addition reactions. First, electrophilic addition reactions. In addition reactions, we will discuss about electrophilic addition reactions. Electrophilic addition reactions. An electrophilic addition reaction is an addition reaction. We are discussing about addition reaction, where in a chemical compound, a pi bond is broken, and two new sigma bonds are formed, and two new sigma bonds are formed. A pi bond is broken and two new sigma bonds are formed. The substrate of an electrophilic addition reaction must have the substrate of an electrophilic addition reaction must have a double bond or a triple bond. It must have a double bond or triple bond. The substrate must, for addition reactions, it must have a double or a triple bond. Understood? The driving force for this reaction is the formation of an electrophile. Formation of an electrophile. Electron deficient species that forms a covalent bond with an electron rich unsaturated carbon-carbon bond, with an electron rich unsaturated carbon-carbon double bond. The positive charge on X is transferred to the carbon-carbon bond, forming a carbocation. This we are discussing about addition reactions, electrophilic addition reactions. Okay. Now, see this. This is carbon-carbon. This is the mechanism. See, this is the carbon-carbon double bond. This is one of the substrate. Okay. Now, it will generate a electrophile. This reagent will generate an electrophile. This is our substrate. Okay. Now, see this. X is attached to this one carbon and Y is getting added to the other carbon. So this is addition reaction. This is addition reaction. Okay. Now, suppose this is electrophile and this is carbon-carbon double bond, electron rich. So this pi bond will approach this electron deficient species and it will form a bond here. This is negative, this is negative, this is this is carbanion, and this is carbocation. This is positive center and this is negative center. Okay, so this will attach here. So this will, the X will form a bond with this carbon, you can see here, and this is the carbocation, electron deficient center, electron deficient center. So this nucleophile, this is nucleophile. Okay, so this nucleophile will attach to the carbocation center, to the carbocation, or the electron deficient center, electron deficient carbon. Okay, so now this is the, in the second step, both the, both this species, both these species get added to the carbon carbon double bond. See, X is added and the Y is added. So this is electrophilic addition reaction. This is electrophilic addition reaction. This is electrophilic addition reaction. Okay, this is the mechanism how this electrophilic addition reaction takes place. Okay. Now we'll discuss in detail. In step 1, the positive charged intermediate combines with Y. The positive charged intermediate combines with Y, that is electron rich, and usually an anion to form the second covalent bond. Step 2 is the same nucleophilic attack process found in SN1 reaction. The nucleophile attacks the carbocation. The exact nature of the electrophile and the nature of the positively charged intermediate are not always clear and depend on reactants and reaction conditions. It depends on reactions and reactants and reaction conditions. Okay. Again, in all asymmetric addition reactions to carbon, in all asymmetric addition reactions to carbon, regioselectivity is important and often determined by Markovnikov's rule. We'll discuss Markovnikov's rule and anti-Markovnikov's rule later on. Organoborane compounds give anti-Markovnikov's rule. We'll discuss about it. Markovnikov's and anti-Markovnikov's rule. Electrophilic attack to an aromatic system results in electrophilic aromatic substitution rather than an addition reaction. We don't have to discuss this one. Okay. Typical electrophilic additions to alkenes with reagents are dihalo addition reactions, dihalo addition reactions. Okay, dihalo addition reactions. This is dihalogen, diatomic halogen, diatomic molecule. Okay, or a halogen molecule, not an atom. Hydrohalogenations, hydrohalogenations, addition of hydrogen as well as the halogen atom. Hydration reactions, addition of water molecule, hydrogen and water hydroxyl ion, addition of water molecule. Hydration reactions, hydrogenations, addition of hydrogen. Hydrogenations, these are not important for us. Only these are important. Dihalo addition reactions, hydrohalogenation reactions, and hydration reactions. Out of these three, these two are important for us. Okay, dihalo addition reactions and halogenation reactions. Okay. Now we come to nucleophilic addition reactions. Nucleophilic addition reactions. Nucleophilic addition reactions. Okay. Nucleophilic addition reactions. A nucleophilic addition reaction is an addition reaction where in a chemical compound a pi bond is removed by the creation of two new covalent bonds. A pi bond is removed or broken. A pi bond is removed by the creation of two new covalent bonds by the addition of a nucleophile. A nucleophile is added, the covalent bond is formed, and the pi bond is broken. Okay. Addition reactions are limited to chemical compounds that have multiple bonded atoms. That have multiple bonded atoms. Addition reactions to take place, the substrate must have multiple bonds, multiple bonded atoms. Okay, molecules with carbon hetero multiple bonds, carbon hetero multiple bonds, like carbonyls, imines, or nitriles. They can easily give addition reactions. Molecules with carbon carbon double bonds or carbon carbon triple bonds. Molecules with carbon carbon double bonds and carbon carbon triple bonds, they can easily give addition reactions. Okay, they undergo addition reactions. They can easily undergo addition reactions, we can say. Now we'll see the mechanism. This is a carbonyl group, carbon double bond oxygen, carbonyl group. This is ketone, CH3 acetone. Okay, an example of a nucleophilic addition reaction that occurs at carbonyl group. This is the carbonyl group that occurs at carbonyl group of a ketone by substitution with hydroxide based compounds, denoted shorthand. We have denoted it by shorthand. In this example, an unstable hemiketal is formed. This is unstable hemiketal. Now, nucleophilic addition to carbon hetero double bonds. Carbon hetero double bonds. Carbon hetero double bonds. Hetero molecules means carbon bonded to oxygen, carbon bonded to sulfur, like this, or nitrogen. Addition reactions of a nucleophile to carbon hetero double bonds, such as carbonyl or nitrile triple bonds, show a wide variety. They show a wide variety. These bonds are polar in nature. They have a large difference in electronegativity between the two atoms. They are polar in nature. See, if this molecule, carbon will be electropositive and the oxygen will be more electronegative. It will have partial negative charge and it will have partial positive charge. So there is electronegative. They are polar in nature. Okay. Consequently, carbon carries a partial positive charge. This makes this atom the primary target for the nucleophile to attack. Now, if we discuss about this molecule, this is a ketone, okay, or maybe any alkyl group. Okay. Now, this is the carbonyl group. Okay, because this is a carbonyl group, oxygen will bear a partial negative charge. It is more, because oxygen is more electronegative than carbon, so oxygen will have a partial negative charge and carbon will have a partial positive charge. This pi bond will shift to the oxygen. This pi bond will shift to the oxygen, like here. It will become negative and the carbon will become positive. So this is electrophilic center. The carbon has become positive. It has formed a carbocation. Okay. Now a nucleophile will come here. A nucleophile will come here and it will attack the electron deficient center or the carbocation to form a covalent bond with the carbon. Now you can see here. Okay, the nucleophile has formed a covalent bond with the carbon. Now this oxygen with bearing a negative charge will find a hydrogen ion and it will form a this alcoholic group. Okay, this reaction takes place in acidic conditions. Acidic conditions. So the oxygen will attack a hydrogen ion and it will form a the oxygen will form a covalent bond with the hydrogen. Okay, so this is this will alcoholic group. Okay, alcoholic group. So this, as the ketone is converted into a alcohol, the ketone is converted into an alcohol. Okay, this is nucleophilic addition reactions toward across a carbon hetero double bond, across a carbon hetero double bond, carbon hetero double bond. and a carbonyl compound. Okay. Right. Nucleophilic addition to carbon hetero double bonds already we have discussed. See, this type of reaction is also called 1,2 nucleophilic addition. We are not concerned with this 1,2 nucleophilic addition reactions. We have already discussed. So this ketone is converted into alcohol. Okay. Carbonyls with carbonyl compounds as as an electrophile. The nucleophile can be water in hydration to to a geminal diol, an alcohol in acetylization to an acetyl, an hydride in reduction to an alcohol, an imine with formaldehyde and a carbonyl compound in the Mannich reaction. This is not important. See again, nucleophilic addition to carbon-carbon double bonds. Nucleophilic addition to carbon-carbon double bond. Carbon-carbon double bond. Okay. Let's see. The driving force for the addition to alkenes is the formation of a nucleophile. Formation of a nucleophile that forms a covalent bond with an electron poor unsaturated system. Electron poor unsaturated system. The negative charge on the nucleophile is transferred to the carbon-carbon double bond. Carbon-carbon bond. Okay. See, this is our nucleophile having an unshared pair of electron, negative charge, bearing a negative charge. It has an unshared pair of electron. This is nucleophile. Now this is our substrate. This is electron rich. This is our substrate. It has a pi bond, double bond. So one sigma bond and one pi bond. So this bond will shift here and it will become carb anion. A carbon having a negative charge like this. Carb anion. Carbon having a negative charge. And this will become carbocation. Carbon having a positive charge. So this electron nucleophile will form a covalent bond with this carbon atom having a positive charge. You can see here in step 1. Okay. And in step 2, an electrophile, this carbon ion will attack a electrophile and it will form another covalent bond with an electrophile. Okay. With an electrophile. It will form, this carbon ion will form a covalent bond with an electrophile. Okay. So this is our product, final product. In step 2, the negatively charged carb anion combines with Y. Y is electrophile. Y is an electrophile. That is electron poor species to form the second covalent bond. Okay. I think this is over. Hello. We'll discuss few more things. Hello. Hello.
Yes, sir.
Now, did you understand nucleophilic and electrophilic
Yes, sir.
addition reactions?
Yes, sir.
Okay. So few more examples we'll discuss. Okay. Or next class we'll discuss addition of HBr2 propene, Markovnikov's and anti-Markovnikov's addition reactions. Markovnikov's and anti-Markovnikov's addition reactions.